Good whenever, everyone. Let's look at section 4.3. More trig. More trig. 4.3. The section is really called Trigonometry Extended to Circular Functions. Blah, blah, blah. More trig. Let's see. Let's talk first a little bit more about angles and how we draw angles in the coordinate plane. So here is my x and y axes. When I draw an angle, it always starts on the positive x-axis. It always starts on the positive x-axis. That is the initial side of the angle. And then I'm going to draw a couple of different terminal sides here. Okay, so I have two different angles there. And let me label them both. Let me see. We'll call this angle. Angles always start on the positive x-axis. And if it goes up from the positive axis, that is a positive angle. So this is going to be 45 degrees. I've tried to draw it at about 45 degrees. Or our new friend, pi over 4. Okay, remember that pi equals 180. So to find what 45 is, I'll put 45 over 180 and reduce it. And you get 1/4. So 45 degrees or pi over 4. Let me see if I got another color here. Here we go. Let's look at this angle down here. This angle started at the x-axis and went down. Okay, so this is, let's say, negative 120 degrees, or 120 over 18, negative 2/3, 120 over 180, or negative 2/3 pi radians. Okay, one or the other. So there's a couple of different angles I put in the same set of axes. Okay, one thing I want to note is that this angle right here, you could, let me just go ahead and draw this again. Okay, so I'm going to look at this 45-degree angle again. So I just really need the first quadrant here. If I look at this 45-degree angle, okay, I could also do this. I could start at the x-axis like that, and I could go all the way around. I could go all the way around and then back to that angle again. And those are called coterminal angles. They mean the same thing. Okay, so this is 45 degrees, or I could say 45 plus 360, because that's another way around, equals, well, let me see, that's going to be 405. And I could add 360 again to find another angle that ends at the same place, just goes around the circle again. Well, what's that going to be? 765. Okay, so if I consider the angle as 45, or 405, or 765, well, those are all the same angle for our purposes, because they always end up at the same spot. The terminal side is in the same place. Okay, when we do these calculations in radians, this is pi over 4. Well, that's plus, what's all the way around a circle? 2 pi. Okay, now I know I shouldn't be telling you these things, but you can use your calculator to do your fractions. Let's see here. What was I doing? That's crazy stuff. When you do calculations on the calculator, leave out the pi and use your math enter. So 1/4 plus 2. Oh, that's pretty. It's 2 1/4, right? Yeah, math enter. So that's 9/4 pi. And plus 2 again, 17/4 pi. So let me get those down so that I look like I'm smart. Okay, so that was 9/4 pi, and then you can add 2 pi again, and you get 17/4 pi. So pi over 4, 9 pi over 4, or 9/4 pi, or 17 pi over 4, 17/4 pi. Those all mean the same thing. They're all this 45-degree angle. So many different ways to write the same value. Okay? All of these angles, we call them coterminal angles. Coterminal angles because they end in the same place. Coterminal angles because they end in the same place. Okay, next. Sometimes they will say to you that they have a point that the terminal side of the angle goes through, and they want you to tell them the different trig functions for that point. Well, let's see here. Let's say I'm going to give you a point. Let's just call the point xy. So here's point P. It's at x, y. Okay, so you have the terminal side of the angle goes through that point. So here is your angle. There you go. Now, we need to draw a triangle so that we know opposite, adjacent, hypotenuse, so we can find all of those things. So whenever you draw a triangle, always draw it down to the x-axis. Always draw your triangle down to the x-axis from the point. Okay, so here is your angle theta. The distance here, the adjacent side, well, that's the x-coordinate of the point, kind of by definition. If I wanted to plot the point xy, you go over whatever the x-coordinate is, and then up whatever the y-coordinate is. So that's x, and that's y. Okay, and just so this picture doesn't get too messy, let's call this side r. A reason we do that is because sometimes instead of x and y for a point, we can use theta and the radius of a circle that will go through that point. That's why we're using r there. It's what's called the circular functions for the section. So that's kind of why we're going to put an r there instead of, sometimes we use a c for the hypotenuse. But we'll use r for here. So r is equal to, let's use the Pythagorean theorem. Well, r squared would equal x squared plus y squared, and take the square root to find r. So r equals the square root of x squared plus y squared. Now, depending on the point, x or y could be negative. R is always positive. Okay, so when I'm using my trig functions, the adjacent is the x-coordinate. The opposite is the y-coordinate, and the hypotenuse is r. Okay, so if I want to know sine, well, it's the opposite over hypotenuse. So I find the y-coordinate and then divide it by the hypotenuse. I have to find the value of r there, and then that will give me my fraction. Okay, the unit circle is when r equals 1. Now you can see, if I set this up so that r equaled 1, that would simplify a lot of my calculations. Opposite over hypotenuse, well, that would just be the opposite if you were dividing by 1. So if r equals 1, we call that the unit circle. I'm going to put a little note here. It says note page 380. Note page 380. Okay, one more little squiggly line, one more thing to tell you, and then I'll be quiet for a little bit. Now let's try to actually use some of this information. Let's say I want the cosine of 1 second here. 5 pi over 6. 5/6 pi. Okay, the first thing I need to do is be able to tell which quadrant that is in. Now, let me set up my axes here. We're going to start here. This is my initial side, and we're going to go around 5/6 pi. Just for a quick reference, 180 degrees is pi, and this is pi over 2, and this is 3 pi over 2. And this is where we start at 0. Okay, well, 5 pi over 6, that 5/6 is a little less than 1. It's more than a half and less than 1. So it's going to be somewhere here in the second quadrant. And it might be a little helpful to think of this in terms of degrees. So 5/6 to 180, 5/6 times 180, well, that gives me 150. So this is 150 degrees. Okay, which also confirms that it would be in the second quadrant, 150 degrees. Okay, I want to look right here. This is First thing to do is draw my reference triangle, and always draw your reference triangle down to the x-axis. And now I need to label this using one of the triangles that I've been given. We have our 30, 60, 90, or our 45, 45, 90 will be the two that we use the most. Okay, and I'll have to set this up so that one of those triangles will fit. If one of the triangles don't fit, we can't do it. Okay, well, if this is 5, 6, there's going to be 1/6 left right here because all the way around is pi. So this is pi over 6. So this is our 30, 60, 90 right triangle. That's going to be 1, 2, square root 3. And one more thing I need to do before I continue, well, the x-coordinate here is going to be negative. So it'll be negative square root 3. So I've finished drawing my picture. And now, to find the cosine of 5 pi over 6, well, here's my angle, 5 pi over 6. And the opposite, cosine is the adjacent over the hypotenuse. So the adjacent side is negative square root 3, and the hypotenuse is 2. So my answer is negative square root 3 over 2. Okay, now you might say, wait a minute, this is pi over 6 in here. This isn't 5 pi over 6, and that's true. And the difference, if I just drew pi over 6, that'd be a triangle right here. And my answer, that would be positive square root 3 over 2. So the difference is that when it comes over to the second quadrant, it's going to become negative square root 3 over 2. And you can check in your calculator with, numerically, and it'll come out to the right answer. So one little device here that I want to write is all students take calc. Which is true, right? All students take calc. Let me get another marker here. All students take calc. And what this is just a little device to teach us or help us remember when functions are positive or negative. Okay? All functions are positive in the first quadrant. Sine is positive in the second quadrant, so cosine should be negative. Tangent is positive in the third quadrant, and cosine is positive in the fourth quadrant. So that's just a little helper way to help us remember where the functions are positive or negative. They're all positive, sine's positive, tangent's positive, cosine's positive. And that's section 4.3.